focusing on the customer and taking care of their needs and taking an active interest in their overall success. When I founded the company 23 years ago, I was asked, what defines your company, James? And I said, well, we legitimately care. We really care about it. We're not just saying it. And it holds true today. So by focusing on our clients, ensuring that they achieve the goals, and helping them navigate and steer on that road of success, they're very grateful, and they in turn either give you repeat business or recommend and refer you to other organizations very similar. So it's really focusing on taking care of your client and building a very strong team that can support the initiatives.
Darren?
Competition for us means something a little bit different. From a Sheridan point of view, we want the best projects for our students and faculty to engage with. And we know there are a lot of great post-secondary institutions out there that can also address the problems and challenges. So for us, competition to us is making sure that we do what we say we do in the timeframes that we want to do it in, and be able to deliver so that we could form partnerships with the companies that we're trying to serve.
Paul, you do policy analysis and competition in Ontario in the manufacturing sector. So maybe you want to grab the mic and give us a thought on
I think
system.
all of the points that have been made apply to manufacturing today. You have to be solutions oriented, listening to your customer, responding to their needs, finding a niche for your product. The only thing maybe I would add, germane to this topic, is that what I find with our members are competing with each other, but they also do find common ground on some of the policy issues that I work on, and use that to mutual benefit. So I don't know if that's a segue or not. But
Yeah, well, I just want to hear from Travis. Yeah. Last one there, and then I actually do want to tie into, how do you find commonality?
Yeah, I got to agree with what most of the guys have said so far. We rely in robotics on our customers quite a bit. They're always pushing the envelopes and bringing ideas to us that they're looking for the robots to do. So as being in sales, I'm never one to say no, and always bring it back to our team. So again, we rely on our internal team to satisfy our customers' needs. The robots are always evolving. Automotive's driven the price down. The competition's tough. So yeah, you definitely need something that's going to separate you from them.
Okay, so let's pick up on what Paul just said. These are all good, and a lot of them are just good old-fashioned business, right? How do you conduct business? But now we're talking about a specific sector of business, and competition is real for all of you. Yet, collaboration is the new wonderful word. So how do we get there? So what are the commonalities, Paul, that you've been finding in looking over the Ontario landscape, if not the global?
One example is around skills, and I guess germane to some of the conversations already here today is that our members are telling us that they're having a challenging time finding and keeping the right people with the right skills. Our most recent survey, 56% of our manufacturing members said they were experiencing immediate skills shortages, and that's only going to grow with demographics and everything else. So that's a real challenge, and everyone's competing for those people, but at the same time there are opportunities for collaboration. For example, we have a consortia approach where small and medium-sized companies and some large companies can host an apprentice amongst the consortia. So it takes some of the risk out of it for the individual employers, and for the student, it gives them an opportunity to see a variety of different skills and types of machinery and equipment and that sort of thing by a consortium model. The other one is around Canada Makes, which is an initiative we partnered with Sheridan actually on, and that's looking at how do we promote the adoption of additive manufacturing across the country by highlighting some of these opportunities. So I think there's lots of room within competition for collaboration.
How much collaboration, any of you, do you actually do, besides with a non-compete like an academic institution? How much would you or could you see yourself collaborating with others in the sector without losing your competitive edge?
Actually, I want to add first to what Paul said. We have to admit that we have a national problem, which is the skills. We have new graduates that are graduating from the universities and cannot find a real engineering or technology job. We are graduating fine young engineers with top-notch knowledge about engineering fundamentals, but they still lack the skills that the industry wants. And Siemens Canada started the academy that I'm heading, and that's an initiative we started over a year ago, but last October we started. And we are partnering with CME recently to have this initiative with all of our competitors, where we are hiring students in their last 2 years in one of our programs called the Dual Education Program. We are going to the universities, and we have started in a pilot project now with our colleagues in CME, and selecting good students from selected universities for now, and hiring them as student employees for the last 2 years before they graduate. We get them into the academy, to the Siemens Academy, and complement what they study in the universities and the colleges with 2 sessions. We are utilizing their co-op terms, and I always use that. We are not touching the cake that the universities and the colleges are providing. We are providing the icing on the cake, or the cherry, or the strawberry on it, whichever way you like it. So that is our contribution. We already hired this year 30 students from 5 different educational institutes. We know that is not going to solve the problem. We want to collaborate with our colleagues from ABB and GE and Eaton, who are in the same industry we are in Siemens Canada. And we chose to partner with CME to be the umbrella that we all work with. We did not even forget about the smaller and medium-sized people who cannot afford to do something like this. We are inviting them to, if they can afford to train take one engineer, okay? So Siemens offered through CME, those smaller and medium-sized, to have 1 or 2 of their selected engineers to join our academy. And we hope, and we really hope, that our competitors or our colleagues from other things to fall track, as we say, and then we can, instead of solving problem of 30 or 40 students, we solve the problems of 500 and 1,000 every year, and that is going to be part of our contribution as the industry to our community.
So have you begun doing the reaching out to the others, and are you getting positive feedback or negative?
CME, that's their job, because again, when you go as a competitor, this is unfortunately the sad part of it, is what's the catch? Why is Siemens inviting us for this? They must have a reason for that. So we found a non-profit organization that, again, it's supported by the government bodies and so on, and we want to make it a national initiative. And I don't want to be talked, so we are asking, Siemens is getting too much focus on education of the new generations. We are doing this globally. This is starting in Canada now. And we know all the statistics are showing that few years from now, our unemployment problem is going to be more severe with lack of skills rather than lack of jobs. We are going to have enough jobs for everybody, but the people are not educated, or they are educated in universities, but they are not capable to get the jobs. And we have to work all, as Canadians, to work together to solve this problem. It's not only Siemens' problem and so on. So that's an open collaboration.
Yeah, I don't want to get too far into the skills gap, because there's a lot of different views on what that skills gap really is about. And and for some people, it's about companies not investing in development and training because they can't either afford it or don't want to do it. They just want the person to be ready. And other people believe it's that they're not being trained properly. So I don't want to get too far into that one. I just want to get into the idea of collaborating and how you do it.
In my world, for me, the definition of collaboration is typically between academia and industry. So the collaborative output and how you extract it and you take it to the real world is usually the challenge. And again, from my world, usually the challenge is the issues around aligning academic priorities with the industrial priorities in a way that it's a win-win situation. What typically gets in the way is intellectual property issues, as one example. So that could be one of the hurdles that can complicate unlocking these collaborative outputs, or even to the extent that it could, be a barrier for companies try to approach universities or colleges in order to establish a collaboration. So I think that's an area that has been hard in my life in the last 20 years. And it's not going away, but I know some institutions do a better job at it than the others, and I think the industry really needs to put aside some of these issues efficiently in order to be able to unlock some of these innovative ideas to be able to compete better.
Anyone else? Down there and then back here.
Personally, I like competition. We differentiate ourselves as Hatch, a company, an engineering company, but I call Hatch an engineering and technologies company. We have a pretty large contingent, over 300 people in our technologies group. We make some of the world's most powerful furnaces, biggest autoclaves, specialty steel mill equipment. We sell this around the world, and we charge a premium. We are not the lowest bidder. We don't want to be the lowest bidder. If a client doesn't see value in us, please go to our competition. We'll still be around when you need it fixed. And I don't mean to sound arrogant. I don't mean that at all. But we really try to do extra engineering work to have a solution. So our collaboration with our clients, we will bring them ideas to improve their process. And our clients are falling short in the last, since the financial crisis and other things, they're getting very, very lean. So they're really becoming production companies. Their R&D groups, their engineering groups are falling down to just supporting their process. So I just left a week conference last week, and I present some new inventions we've patented. Everybody's happy to see some new ideas, to get some proposals out there, go and do some tests. And yesterday one said, yeah, come on down in a couple of months, we'll do a test. So it's a new process improvement. Small, but it'll be worth a couple $1 million a year. This is the kind of thing where they say, we're happy. This is why we come to a conference. We don't have our own people to do this anymore, and you're stepping up and providing this. And my competition, eat my dust. I mean, not to be rude about it, but they're trying to compete on a price basis, and I'm trying to compete on a smarts basis. So competition's good. Collaboration for me with a client when they see the value, that's also terrific because then they rely on us. So we develop a very deep relationship where they use us as a trusted advisor, and they don't really see us as a competitor to the other guys anymore. So in support of what Sheridan has done, Sheridan is providing a nice playground, if you called it, where we can develop some of this technology. We don't have our own model shop, but it allows us to demonstrate some of our technology, such as a robotics lab, and a client says, I get it. Great, you're proven, even though it's not in production, but it's here in the playground. So it's worked out well.
James and then Farzad.
The collaboration that we engage with is really helping create the partnerships between industry and the institutions. We spend a lot of time supporting the initiatives of community colleges and universities right across Canada, many of them in conjunction with CME and Canada Makes. It's really trying to create that relationship with an industry partner and the academics. Both are looking for the same type of knowledge and support. We have to learn about additive manufacturing. Schools need to learn about it. Industry needs to learn about it. So we try to set up events where we can go and share and enlighten on the topic at the same time, make the introductions, and then support that relationship. And we're seeing a lot of success in the various communities that we support, and more industry partners are starting to work very closely with the institutions. And any shortfall as far as product knowledge, capabilities, application support, we're there to support any of the initiatives and to continue that collaboration in education.
Okay, Farzad, and then I want to talk about internal collaboration.
Yeah, so here at the Center of Advanced Manufacturing and Design Technology, we promote collaboration, and really, when we say the collaboration, there is no place for competition. And look at the table that what we have here. We have a ABB, Hatch, Siemens working together. It is a art of the communication to talk to these guys at the high level to say that you have a place and a role in this collaboration, and there is a mission and vision behind that, and everybody buy that and come here and play nice. And when Bill was mentioning about the Hatch robotic project, it was done by ABB, but in a safe environment. So the key is create a safe environment ecosystem that the company like a Siemens and the ABB can find their role. And there is a vision and mission. That is, yes, the vision is that we know, all of us in this room know that there is a skill gap within shortage of skill within 5-10 years. And if you don't collaborate, you don't get it. Done. It's a dictatorship here, that's what we discussed. If you don't collaborate, Siemens don't collaborate with us, you don't get it. And after that, who is suffering? Because I can go and teach other disciplines like accounting, art, and everything else. But you are going to suffer. So we have to understand that. We have to collaborate, and there is no competition. But we have to create this understanding. We have to create this way of the ecosystem that we are not competitive in this setting. In outside, you wanted to compete with ABB because both of you are in a power system. You are the best of the best in the world. Do it. But when you come to the center, we collaborate, and the benefit, you know, that the students get the best of the best from the Siemens, from the Hatch, from the ABB, from the Symmetrics, from the CME. Why we went and established the maker, Canada Makes, across Canada. And we are in a talk. I will be in New York in April 16th to bring the Canada Make with America Makes. Why we are doing that? Because all is about the collaboration, and this is what we mean it really.
I just like hearing Farzad say suffer over and over again. I don't know why. Darren?
I just want to add a different perspective, because what the discussion on collaboration in companies, I think there's a huge need for industries to come together to set standards. So if you don't have a technology bar at a certain level, then everybody in the industry has to come together to understand what that bar is, and then work together to set the standards and set the metrics and how you don't improve those standards are where they need to be. So there is a need among industry and to work with academia in a safe environment to help establish protocols, establish what these levels are, so that the industry can continuously move upwards rather than stay down or go latitudinally, if that's a word.
Latitudinally?
Yeah, something like that.
Okay, one more thought on this.
Yeah, I want to add, I want to thank Farzad for what he said. He brought a very good point. It's collaboration happens between partners, and partners have to talk to each other. And partners in business, in education, there must be a common denominator between different partners here. And traditionally, and I hope everybody understand me not in the wrong way. Traditionally, the relation between the academia and the industry was, give me equipment, put it in my lab, I'm gonna use it. I'm not gonna use numbers here, but we have our equipment in a large number of educational institutes. And it breaks my heart when I go and visit now for another mission talking about students and so on, to see those equipment not used. So when I work with Farzad, and I'm not saying this because Farzad is here, I am working with an equal partner. As he said, if he doesn't work with me, he is going to suffer. If I don't work with him, I am going to suffer, because we are both stakeholders. And that is we can talk about, citizenship and patriotism and all this stuff, fine. But we must work for value for this collaboration. That is time is very valuable for all of us. We have a common cause. We have to work. The equipment is there. The software is there. Okay, but it's not a stamp collection competition. The technology is there for you to use it. The technology is there to train the students. Then if the students are trained, then I'm going to benefit from those students. I'm going to get good engineers. ABB is going to get good engineers. It doesn't matter. Your students are available to everybody, okay? Then we have to compete in a very, very positive way. Who is going to attract the best students out of this? So the collaboration has to come. When we see a center like what Farzad is building here, it doesn't matter if it's ABB or if it's Siemens or if it's anybody else. We have a Canadian center that we all should be proud of. We will be compete to have part of that and be a showpiece for all of our Canadian or global technologies that we offer. We need the instructors to utilize that available softwares and hardwares and knowledge for our students, for our kids, for our sons and daughters, to be our future engineers.
So
That's what I'm thinking.
thank you. So how do we, well, one thing is, how do you define play nice? I'm interested in that one because I want a T-shirt, Sheridan Play Nice, Camden Play Nice. Because there must be some sort of protocol to, like, whenever you create a collaborative center, it's all about the sandbox, right? Now, I have 4 children, and I've definitely seen behavior in the sandbox, which was not cool. So you can create a sandbox for people to play in. It doesn't mean they're going to play nice. And then there might be a moment where some fabulous idea came up. Who owns it? Where's it going? And how are you supposed to manage it? These are tough parts of collaboration, right? So some thoughts around that would be helpful. Okay.
Play nice. Doesn't look like, but I am very shy to ask. So I usually don't go to Siemens or the ABB to ask something. If I am not working for that particular thing that I'm looking for 5 years before that. So we are all thinking about the multidisciplinary engineer and the engineer who understands the system thinking, an engineer who can work in a system, and we are playing in a silo. So one thing that Sheridan did before even asking, before establishing the center, is collapse all the silo. We integrate all the engineering discipline, what we are teaching here, to show that really we are thinking a system thinking, and we wanted to have our students think of a system thinking. And here is our electrical engineering, manufacturing, mechanical, computer engineering, all in the under roof of the one school. And our faculty are multitasking, teaching in the world, and the students work on the project. That, you cannot get it, it is very difficult to achieve. But when you achieve, now you have something to show to these guys. They said, I play nice, I did my rule. I put a platform for the system thinking, and to have the whole multidisciplinary here, around here. So now your job is to help me to go to the next level. So this is the way of we think that we are nice because we are creating this environment before even we are asked.
So more thoughts on internal collaboration. Once you're in, what is it that makes this a special experience and worth doing? Does anybody have any thoughts on that? Well, I just want to see, go down to the...
I'm not sure if I really understand the question.
Okay, so it's one thing to say, how does the whole ecosystem of Ontario, for instance, and, you know, through Canadian manufacturers and exporters. So there's a way of playing in that collaborative space, and we've sort of established some of those ways. Once you're in an institution, even in your own company, how do you foster collaboration in a true sense? Because what we've noticed in our own search through creativity is often what happens is the person in your organization is rewarded for operational excellence. You do your job, you do exactly what you were asked to do, you do it well, excellent, you are a great employee. But they're not often rewarded for lateral thinking, for failing, for trying. So you end up with the Gore example. So Gore Industries, chemical engineering mostly, they have a cultural way about them where they say, okay, if you can convince 3 of your fellow employees to come together with you on this idea that you have for something that might work, and you present to our executive group and we say, yes, we'll give you money and you can go try it. So they do that and they come up with it. Now, if you fail, they call you into a meeting in the boardroom and they throw you a champagne party. And they say, excellent, try again. So that's a totally different way of doing business than the other way, which is you screwed that up. We don't have time for you to screw that up. What are you doing? So how do you get great new ideas when innovation itself is in many ways partly accidental? So how many brilliant engineering things came about because somebody was looking this way and they found something that way? You know, penicillin wasn't being looked for, insulin wasn't being looked for. All kinds of amazing things were not what was being looked for. So how do you create internal collaboration and creativity in your organizations? Or how do you do it now in a way that works? Or are you doing it?
I think at ABB, it's more of a teamwork for most of our projects. Most of our projects are larger, and there'll be numerous engineers, project managers, specialists in that area that work together, along with collaborating with the customer to find the solution. So, and there's always got to be that end result. So, not necessarily there may be a failure, but then there has to be the success for the project to go on. So, if you if you fail at first, try again.
But do you try again, or do you go, what did you do? The customer's waiting.
No, it's a application that's, we have to find an end result for.
Right. So teamwork and project orientation.
Yeah.
And do you work that way with everything or just some things?
And it depends, larger projects are worked that way. When it comes down to maybe a single robot, no, there'll be more, either just a sales guy, maybe one engineer. But yeah, there's at least 2 people working on a project.
Okay, anyone else?
It really comes down to the type of culture that you create within your organization as to how the team members will play with each other. Ultimately, there's one mission. Everyone understands it. Everybody works towards that. Everyone has their own individual goals and objectives that they are accountable for. But at the end of the day, irrespective of what the task is, the team collectively gets together to support that initiative. And it's really how I structure my company. It's the attitude in which I run the business and what I expect from the team members. Everyone is there to help each other, irrespective of whose fault it was, who made the mistake, or who was the one who came up with the solution. They're motivated to work collectively together, like you would, any parent want their kids to get together, help each other, don't jump on each other. So it's really up to management and the culture that you want to create within your company.
I would say within Hatch, we have 2 kinds of this creativity. One would be on projects where we could have hundreds of engineers at any one time for 6 months to a couple of years. And we encourage them to be creative, add value, work with the client, try to come up with a better solution, address costs, address schedule, address production, etc. So that's very much a collaborative team effort with multidisciplinary approach. But then again, we have the individual, the inventor, the crazy scientist on the side there with an idea, who's going to try something a few times and keep on trying. And I tell you, we got some sci-fi weird ideas cooking around within Hatch. I won't tell you about them, but they are like 50 years out. And some managing director has to say, there's enough in here that we should at least sponsor it. And we know we're not all the way there. We know we can't finish. We can't get to the finish line by ourselves, but let's get to the next step and see if it keeps on going. So For the individual, hopefully we provide an environment and enough management support and some money and some funding to allow it to progress on that nice famous stage gate type process to carry on. And if it fails, well, you know, we learned something on the way. It wasn't a failure per se.
Right.
So there's the two approaches. There's a project approach and then there's the individual.
I'm not going to talk about what we do in Siemens about innovation. It's not because it's a secret, it's common sense. I want to go back to collaboration with the educational system because that's my passion. I think we need to talk. We need to meet more frequently. We need to feel each other's pains. I mean, I can give a very good example. I met Farzad about a year ago, in a Halton Innovation Gathering. Introduced ourselves. This ended now with Sheridan being qualified for our Siemens Mechatronics certification system. So big decisions, big contracts, big collaboration always start from people talking to each other. The more we have non-business forums, the more we get successful and healthy business relations. Because if you start with business, then it becomes opportunistic. If you start with people with cause, and then it gets better when we have a common cause, and we see each other's capabilities. We talk, but we don't know each other. Most of the time, universities, when they call Siemens, they end up talking to a sales guy. And don't blame the sales guy, because the sales guy's job is to sell a product, okay? But you don't talk to the people that we have in the talent acquisition, in the academy, in the corporate levels, people who know what Siemens is doing, and so on. I'm talking about Siemens, and I'm sure other bigger Hatch and ABB and other bigger corporations, they have similar relations. So the more we talk on a that is the point I'm going to try to make, and I'm re-emphasizing it on and on, because that is what's going to bring the healthy relations. That's where we are going to look into what you really need from the industry. That's where meetings like these, that we share and we listen to each other, and we listen with passion, and we listen with understanding. And that's where we should start. And we know what are the needs, what you listen to us, what do we expect from, because we talk about skills. We have never went enough. We talk of the same thing. We need more skills. We need icing on the cake. But what is really that we industry need? And maybe Siemens have different views from ABB, and maybe the guys in the FASCO have, but the universities, what are they going to do? Who are they going to satisfy? Then we can come back and we keep talking about curriculums and revamping the curriculums and changing, but nobody goes into the operational side. We are still here in the high level, 30,000 feet level, but we need to take these discussions into more operational, into more directive, and beneficial for everybody.
All right, Paul, some best practices that you've seen around the idea of what creates internal collaboration in a successful manner?
Yeah, I was thinking about this in terms of my experience with CME. I mean, CME as an organization came together 140 years ago, or whatever it was, 1871, whatever that is. And but it was because a group of competing manufacturers, many of them competing, came together and said, you know, if we can build a stronger economy for the country, we can all be more successful as individual companies. And so it's part of our kind of DNA. But also today we find that the problems that we're faced with are, you know, much more complex and not something that as an individual organization we can solve. So it's really by virtue of necessity that we realize that we have to collaborate in order to be successful ourselves as an organization and as individuals. But you know, to achieve success in some of these areas, the skills issue is another, you know, a great example where we're not going to fix it by CME going out and talking at these things, but by working together, we can chip away at it, and that's where we've really, had some great results. And I mentioned, the consortium model, the collaboration we have with Siemens, with Sheridan. These are all parts of, working towards the bigger challenge that we're all faced with.
All right, let's, Darren, did you want to say this? Yeah, okay. After that, I'm going to ask if anybody has any questions.
I think what is important to realize is internally or externally, you have to make giving time to meet with people and giving the conditions of serendipity a priority. So, if, coming from industry, you have 100 things on your plate. Coming from academia, you have 110 on your plate. Then somebody comes and says, I want you to take a few hours, a day off, and meet and go and meet with people. And you say, I'd like to, but I can't. So if you're saying what will drive collaboration is raising that on the priority and saying, no, I must do that, and something else will have to fall off. But I think giving the conditions and finding ways of bringing people together, whether it's mashups after work, whether it's lunch and learns, whether it's just creating the condition and environment where people could come together and get to know other people, to understand what their challenges are, and then give the opportunity to have those meetings, say, well, why can't we do something? Why can't we do something?
Maybe Google time wouldn't hurt, right? I mean, the whole Google plan, I remember reading the last book on Google and realizing these are all engineers. That's why when they get together to say, so how do we think it's going? They're engineers. They're all about what's the problem, how do you fix it, problem sets, how do you get through them? So they have these fantastic meetings with their CEO where it's not just carping. They're actually going, I think you got to fix it this way or that way. So when you're talking about what you're talking about, I'm thinking, well, what everybody needs is an ability to talk to the people that they work with to say, leave me alone one day a week. Just leave me alone. Trust me, I'm not going to play tennis, and let me hang out with people. Because what we find with collaboration in other aspects, like in design and in art, in social innovation, is it's hangout time that matters. It's not like you got to be productive. It's just you got to be in the kitchen at the Center for Social Innovation at the same time as this other person's in the kitchen, and you go, what are you doing? And they go, oh, I'm working on a sustainability audit process. Oh, well, I'm working on a sustainability product. Next thing you know, they've got something going. So it's bump into each other time, right? Which is hard to do because we're not rewarded for that or incentivized for that. All right, do we have any questions from out here from people? Because you sort of heard from the group a fair bit, and we do have to move through. Come on, folks, you can do it. Somebody back there? Good, thank you. Sold.
Hi, my name is Michael Cook. I just talked with James at lunch there. We were talking about things like basic skills. So we're trying to create outputs for your inputs. But what about the outputs we get? So I'm teaching first-year math communications. They can't add and subtract fractions. They can't read and write. They don't know how to use commas. So when we say, are you looking for your panel, what even in the high schools or in the elementary schools can they do so that they're more prepared for us so that we can build on top of that and not have to reteach a lot of stuff? And then are you also having to find the same thing? Are the outputs we're giving you stuff that you need to reteach? There's some comments on that.
All right. Anybody have some experience with outputs? Nobody?
Well,
Siemens.
That's what I'm doing for a living now. I mean, I just left the division in Siemens and I took the academy in last October. We are looking into what you guys are teaching and I take that with a lot of appreciation and respect. It's what's missing is the management skills, the vision, the strategy, the soft skills. Like, I don't want an engineer who come, and I'm gonna speak as a division head before the academy. Somebody who sent me an email as his boss and ended up with an LOL. I'm just making this like, okay, or wow, this is I don't know what, okay, and that may be fine. I can accommodate it. I have kids and so on. But if he talks to the customer like this, or if you talk to my consultant on a big project at Hatch, the guy from Hatch said, "What the hell are these guys hiring?" Okay, so that's we start from those types of skills, and you're right. We should teach those skills on a high school level. Our education on the soft skills has to start from the high school level. We do not, in the industry, expect from the universities to teach them everything, because, and again, I spent 2/3 of my life in engineering and teaching and working. The universities would teach fundamentals and concepts and systems. So the problem is on the industry. We are not investing as we used to invest 10 years ago, training the engineers. So we should do that. But if we talk to each other, maybe you can incorporate them in your curriculum. What we are doing in the tech, specifically in the academy, and I know that's debatable. We need soft skills. We need vision. We need creativity. That's what we talked about. The guys, we don't need more book-smart kids coming out of schools. We don't need more 4.0 GPAs that they cannot solve a problem. Okay? We don't need people who cannot read a map, okay, but they can solve a mathematical problem. Because if I get somebody and send him to Manitoba and he cannot find his way because he doesn't have common sense. So I go with all this, is we need to teach them common sense, because engineering is about logic, is about common sense thinking, it's about problem solving. We talk about all these words, but we just talk about it. These people, engineering is a way of life. We need engineers who know how to think, not to think to pass the exam as we talked this morning. We need engineers to know, progressive thinking, logical thinking. When you give them a problem, they take it, analyze it to the atomic level. And so I can speak about this because I've been spending 6 months just doing this. What should I include in my curriculum? What am I going to teach my future engineers in Siemens? And these are the topics. Now, we are giving feedbacks to our partners. Can you do this in your curriculum? You cannot do that. And as far as that said, you cannot teach them everything. And what Siemens wants is different from what DeFasco wants and what the other guys want. So it's a dilemma. But we have to agree at least on a minimum base requirement.
Down there.
Maybe you have another conference for that.
Go ahead.
I can't speak to the quality of a math problem or something of that nature, and I really think that the graduates are cognizant and sensitive enough that they have to prove out their own math equations, et cetera, but we have guidance. But I'm asked to speak to the new employees at certain times of the year, and I give them 3 words of advice to be successful in their early career. The first is to be creative in anything they do. Doesn't matter if it's administrative or engineering or project management or site work, be creative. Makes it more fun. Second is to be proactive. You achieve more, you get more done. People want to work with you because you do get more done, and people don't want to chase you to get stuff done. This is a nice way of saying do more, but it's there. And the third one is be kind. You want people to work with you. You want them to want you to work with them. And it's culturally better because we have enough, let's say, stereotypical older engineers who are not kind and who are just stuck on the technical side. And that doesn't work anymore either. So those things, if you can advise the students as an output, being creative, proactive, and kind, there's probably more, but those are pretty good 3 aspects to look at.
I have a question. What has changed? Do we have these same issues 5, 10, 15, 20 years ago? Well, what has really changed? Is it such that we took our eye off the ball, that we kind of fallen behind now where things have turned around somewhat for us on manufacturing? The weakness of the Canadian dollar is bringing more business into manufacturers, and they don't have the luxury of time to train, nurture, and bring people along. They need people to come in and apply and contribute immediately. The pressures are there, but what has changed? All of a sudden, we're scrambling to fix something. And when did it break? How did it break? Why did we let it break?
Anybody have an answer out here on what's changed? Heck, even I have one for that. Nobody has an answer for that? Maybe the speed of change?
Well, definitely, things are working at a faster rate today
And
than they used
maybe
to be. We don't have
the
that
nature of work?
luxury.
what is work in North American society as opposed to what work was. So if you worked at the Oakville assembly plant, you had a good 30-year run. That's over. It's over. And the rapid sense of change, well, 3D alone is enough to blow your head off. And I just saw a TED Talk I got to watch, a guy named DeSimone, with a process to accelerate 3D printing iteration by 100 multiples. So what changes, I think, is that change is normal. The static is change. There's no static anymore. There's no stasis to it. And you're constantly having to move forward, I think, right? Does that make sense?
The pressure on the, it makes sense, and the pressure on the institutions now is to generate a product that is fully functional. You don't have the time to mature, develop the skill sets, because industry is under a lot of pressure, and they want ready-made students.
Just-in-time students.
It's not going to happen. So if it's going to happen, the collaboration that we've been talking about has to start from the middle school, high school, college. We have to start developing that. And I don't know if and any collaboration happens between the various levels of education. You know, if there's a certain skill sets that you may want or necessary to have a fruitful experience at the college level, and you need certain skill sets developed at the high school level, can that happen? Is that communicated down to the variety of different school boards? Everyone's doing their own thing.
Yeah.
So as much as collaboration within industry, what's happening within the institutions?
All right, we have a question here.
You were asking
Yeah.
what changed.
Yeah, what's changed?
I think what changed is that people ran out of patience. 30, 40 years now, industry have been asking, how come new hires cannot engineer immediately upon graduation? Well, you can only wait so long. Us in universities forgot the fact that if we always do what we always did, we will always get what we always got. We keep thinking that if we do the same thing, maybe this year it's going to be better. And then comes CDIO. Here's an answer to the problems that you folks have been having. Can we educate engineers so that they can engineer immediately upon graduation? Can we educate them so that they have feel for things? I think that's what changed. People have run out of patience, which is a good thing for us. We kind of need to be pushed a bit. And
All right,
it's a good thing.
Dave's got over there. Dave over there.
And by the way, how many of you allow your kids to change the oil for your car? This is change. This is change, James. You don't allow your kids to be dirty, to go and break something and fix it. And by the way, how many of times your kids beg for something? Everything's ready. We were begging for that it beg means negotiation. We learned the negotiation when we were 5 years old. Now the kids are not negotiating. It's ready.
Yeah.
I won't tell my kids that you said that.
Yes, you will.
Maybe I'll threaten them with it.
Exactly.
So Dave Wackerlin here, and I look after the architecture school and chemical school at Sheridan. And one of the similarities that I see between those two very different streams is the hyper-specialization in industry. And this competes directly against the idea of us somehow as academic institutions outputting people who haven't yet interacted with industry but somehow arrived here ready. If you need somebody who's an expert in this one very narrow part of a field, the example that I would give is going to be a building example. I was recently an inputter on a fairly large building that had more than, when we all got together to speak about the project, there were more than 30 consultants in the room. And each one of them had one hyper-specialized region of that building. And they were actually mostly engineers. They were all different kinds of engineers, although they were probably all graduates of the same schools. So one of the things for us to work through is how can we partner together, industry and academia, to begin to train people for both the ideas and the applications earlier on in their educations. And I think we're seeing that through initiatives such as CAMDET. How can we expand those initiatives? How can we get students interacting with partners very early on so they learn about those specializations and fall into the right career?
Anyone else? Anyone back there? There's someone all the way at the back, as far as that's getting his exercise.
On the question of what has changed, I think not an awful lot has really changed, but some of us have become more aware of it. When I was an undergraduate quite a long time ago at the University of Waterloo, there were already at least one university and a bunch of employers who thought that getting engineers doing engineering before they graduated was important. There are more internship and co-op programs now, but we still have a lot of engineering students graduated who have never participated in a real engineering endeavor with an employer. And we have a lot of employers who aren't willing to spend a little bit of money on getting engineers before they graduate into a position where they'll learn, but maybe not be as productive as you'd like to. So I think we knew a lot about what the solution was in the 70s. We didn't implement it. We're getting better.
Good point. Darren, did you want, oh, two, Paul and Darren, okay? Go.
Okay, so, sorry, just on the issue of industry and I guess their, responsibility and how do we engage young people and more effectively. I think industry is coming around to this notion that they have to get back into the game of training and engaging people to solve the skills issue. There may have been a bit of a lag there, but certainly with things picking up in manufacturing, there's an immediate demand that we know is going to get worse from a skills perspective or more challenging. So we're working with industry, with manufacturers, with other organizations to try and address that. We have a couple of examples. One is we're doing a program with the Aerospace Council, Canadian Nuclear Association, and Tooling Association to do some CNC training. So we're taking young people, students, actually putting them through training with industry, hands-on stuff. And then, industry manufacturers are hiring those folks at the end of it, which is great. The other one is a program that we have with manufacturers called Open Doors, where we're actually going to getting high school students and taking them to experience advanced manufacturing, getting them into manufacturing facilities, talk about the career opportunities in manufacturing so they can start to get their heads around, what is this all about and where can I go from a career standpoint at an earlier stage.
Darren?
putting robots in the lab downstairs and getting the students more familiar with, with not just our product, but robotics in general. And our customers are using facilities as well with current projects that they have. So I think just expanding on that, I think you guys will see, if you haven't already, the lab downstairs is very impressive.
All right, next.
I would start with a congratulations to Sheridan for the initiative of this facility and the CDIO initiative. I would say we contribute to other universities as well, and to be honest, your level of this experiential learning is beyond what we've found in other academic institutions. But I would also say that although this is a very good initiative with the students, there's still more opportunity. There could be more on the incubator side where you're also working with the employers working there, not just the students. So there's a little bit more of somewhere in between, in a gray zone in between. And I don't think that is really existing as yet. Not to say that it won't in the future, but congratulations for how far you've come.
So I guess I'm just going to state the obvious, sharing a common vision that your success, whether you're a company or you're an educational institution, is really connected to your neighborhood, to your community, to your city. So having the passion and realization that you have a role to play in that ecosystem, it's very important. So there's a bigger cause, and I think sometimes we have to remind ourselves that it's important to not lose the vision of the forest from the trees.
I'll keep my comments brief. I just want to leave with a feeling of optimism. The fact that so many people were willing to take their time to come together in a meeting, to me, is really encouraging. And I think speaks well for the future, that where we don't work together to solve problems and find new ways of doing things. So I'm filled with a sense of optimism, and I thank Farzad and CDIO for organizing this event.
Well, I think, I want to conclude with this. We don't have a choice. Academia and the industry, it's not a marriage of convenience. It's a marriage, it's a Catholic marriage, okay? We have to live with each other, we have to work with each other, and we have to survive together. And when we aim high, we may not reach it. And I'm answering the two colleagues here. You do not have to have a lab from the industry to make the collaboration successful. You don't have to get a software to be successful. I just want to ask, when was the last time you asked somebody from the industry to come for an hour to speak to your students? When I went to university in the 70s, I'm an old guy, not like I look, but when we went there was at least every month somebody, and I went into to school in a third world country. We had somebody from the industry coming to talk to us about the experience in the industry. So those guys would come volunteers, it's not going to cost you too much. And these guys, that's how you pull them into your life, talk to your students, they get involved with the university, so the universities are not in the ivory tower. They come to speak, the next thing you ask them for a capstone project, next thing you tell him if they can if he can help you in the lab, next thing he can help you with the software, you end up with an R&D project, and here you keep things rolling. We have to start from somewhere, and the 1,000 miles journey starts with one step. And I'm really happy that I came here today to meet with all of you guys and to listen to you and talk, because that's important. We need to listen more and more and talk to each other. Thank you very much for the opportunity. Thanks, Farzad.
Thank you, Farzad, and thank you, CDIO, for inviting me to participate in the event today. At the end of the day, the responsibility is everyone's responsibility. It's not the institutions. I think it's collectively with the institutions, industry has to work together to solve this objective. We're all going to benefit from it, just like collectively we're going to work together and collaborate with the industry partners to see how we can bring our skill sets, our technology, coupling them together to help solve business issues. It's not all doom and gloom, even though we kind of focus on the negative side of things. There's so many positive things that are happening, many initiatives right across this country, if I look at what's happening just south of the border or happening on a global scale, we're in good shape. Yes, we have a lot of challenges, but I think we're on the right path to solving and overcoming those challenges.
I don't want to repeat everything that's been said, all great comments. I'll just say collaboration works, and thanks very much for having me. Great discussion.
First of all, our president isn't here not out of neglect. He's here in another part of the building, which I'm about to return to, where we're doing the executive board retreat. So we're doing a strategic creative problem-solving session right now, which I believe you'll be doing. And so he sends his regrets and is looking forward to hearing from Farzad and Ian about what this was about today. I'll just throw in one last comment about what innovation means to me, which is Dr. Anil Gupta from India did a presentation a few years ago at the Mars facility. And he was talking about frugal innovation. Not expensive machines, but the right solution for the right person. And the key for him for everything he did was compassion. That if you put yourself in a place of true compassion for the people of whom you are creating a product, you will be able to feel and sense and understand exactly what's needed for them without trying to be clever or without trying to repeat your last success. But instead, you'll be focused on what is this person's problem. So when the problem was that women were carrying enormous amounts of water on their heads and that they were getting collapsed vertebrae, he put himself in their position, and he created a situation where every eighth of a mile there was a stand about head high for the average Indian woman, so she could take it and move it over there, and then there was shade in a well, and they could get some water and relax, and then come back and by themselves, because there's nobody to help them, put this thing back on their head and keep going. And that was an engineering innovation. So as long as we keep our hearts open to what we do, the creativity comes from there. It doesn't come from here. It comes from trust and compassion and some guts. So I wish you all of those things in what you do. And I now have to run. So.
Well, yeah, one quick comment. Sky's the limit for our colleagues in Sheridan. Please accept my compliments. This is really awesome. Looking ahead to what could lead to, there's one topic that was brought up by one individual that we didn't pick up on. Mr. Nazarian said the IP ownership, working with your partners, if you could establish a framework for it, especially when MS theses, PhD dissertations, and so on are available, as I see it, honestly, sky's the limit for you folks. I'm impressed.
Ralph, thank you very much for your moderator. One thing I forgot about Ralph, our collaboration is the reason, because he was asking about the collaboration. He wants to do his next house 3D printed, one pair of the shoes, and one internal organ. But we have NDA, so I don't tell you which organ he wants to do the producing. Thank you very much, Ralph.
Thanks, Farzad. No, I get a parting treat.
And this is, I have to show you. This is again the 3D printed. The house that you are going to print, this is the first decoration that I want.
Thank you very much. Well, very appropriate. Thank you, everybody.
And thank you very
Gotta
much
go.
for the panel. Thank you very much. And really, your collaboration means a lot for us. And as a we will have a tour. I will go and catch that. Yeah, thank you.
Test, test.
Can you hear me? I think it's on. So we're going to start on the workshop now. So if I could get everybody seated at 5 tables, the tables that have paper at them, and we should try to distribute ourselves so that there's equal number at each table. So here we have 2 people, here we have 4, here we have 5, here we have 5. Actually, I don't think we're going to have, let's do 4 teams. So if this table back here doesn't mind moving up and assisting this table of 2, that way we'll have 5 people there. Okay, so we have 4 people here.
I gotta go in 10 minutes.
Oh, so we're going to have somebody jumping ship. Okay, and then we have 5. Okay, that'll be good. If they can move forward, then we should have the numbers distributed. Okay, well, this project, what we're going to be doing, and hopefully you can see it from the back, this is a project-based learning exercise that takes you and puts you in the mode of the student. So for the next 2 hours, you are going to be students working on an exercise that your students would work on. And in the process, what we're going to be doing is I'm going to ask you, while you're doing the project, to complete and add things to a rubric. We have 2 different rubrics, but I want you to think about ways that we can assess the creativity of students as they go through these exercises. So what I'll do now, I'll pass out some of these rubrics, and there's one example on each of the rubrics that you can refer to. But as you're going through this exercise, what I would like you to do is have 1 or 2 people, and these thoughts will come to you as you're going along, about ways that you could assess the creativity of your students when they are going through this exercise. So part of this is about how we assess creativity in project-based learning activities. And so here's the other set of rubrics that are coming through. And I would like to collect these at the conclusion and then try to summarize them and send them out so that we can share what people come up with in terms of creativity. We did this exercise in Medellin, Colombia last week, and we weren't doing creativity, we were just doing how do you assess students, but those rubrics were created in Spanish. And so they will be creating those rubrics and then distributing them for everybody that was involved. So the topic, what did I do with my mouse? One thing that I'd like to say, Farzad, you know, you made a little bit of an error. You said Ralph Ben-Mergi didn't really have any engineering background. He actually guided me through undergrad. From 1985 through 89, I used to listen to CBC Nightline every evening between midnight and 2 a.m. And that's when Ralph Ben-Mergi would be on, and he was playing music. And so it was quite the treat to hear when you said Ralph Ben-Mergi. I said, it can't be the guy from CBC. And it was, yeah. So please do tell him that he got me through engineering.
by listening to his music. I was writing labs, doing assignments, things like that. Okay, so this project is called Les Halles. Has anybody been to Les Halles in Paris? Okay, so some people know what I'm talking about here, but this will be an advanced workshop, and it is called Les Halles, and I'll explain to you why it's called Les Halles in a few minutes. But Les Halles was referred to as being the belly of Paris. What Les Halles is, it used to be the fresh food market, which is in the downtown region of Paris, and it dates back to like the 1100s, when the merchants would come in and they would sell their fresh vegetables and things like that. And then the king at the time decided, well, I'm going to put a roof over this so that the people that are selling, the merchants, actually can stay out of the rain and things like that. So it became known as the belly of Paris. And then in the 1800s, what they did, and it's kind of hard to see, is there any way to dim the lights in the front so that people can see the screen while we go through this? What they did in the 1800s is they built a series of steel pavilions that are over where, thank you, Farzad, there you can see it. They built steel structures, and that is how Les Halles existed for quite some time. And then what happened in the 70s, it was in dire need of repair. So they made the decision that they would disassemble the steel structures, and they sent them all over the world, and then they dug a really big hole, and what they put there was a train station and a shopping center. So there's an underground shopping center, and one of the main metro stops, as well as the RER line, comes through Les Halles. Now, on the surface, above the shopping center, they put this beautiful architecture here that you can see, but it was despised by the Parisians. Parisians are quite discerning with their tastes, and they did not appreciate that. So what happened, they called it soulless architecture. So in 2007, the decision was made to level it and demolish. They kept the shopping center underground, but they kept what was on the surface of the park. And they went through a process of coming up with a new re-envisioned Les Halles. So this is the city of Paris, just to give you a bearing where things are. That is the Notre Dame Cathedral in that area. The Louvre is in that area. The Pompidou Center is indicated there. And then finally, Les Halles is right in that area. And Daniel, you can correct me if my accent is totally wrong with the way that I'm saying it, but yeah, okay. So anyways, this is a zoom of Les Halles, of the new reimagined and what is being constructed right now. But you can see there's a region here with a canopy, and that canopy is to kind of echo back to the old market. So it's an open air market. You can walk in, well, it's an open air region under that canopy. But that is the vision, and that should be done by 2016 is that when they will complete it. So as they're building that canopy, and it just so happens that I was in Paris a couple of weeks ago, it's probably a month ago now, and a horrible thing happened to me. I was to depart on Friday morning on an Air Canada flight from Paris to Montreal, and I decided to check my emails before going to the airport, and I see these emails from Air Canada saying my flight had been canceled. So I had to spend Friday night in Paris without anything to do. And that was kind of unfortunate. So what I did is I went to the Pompidou Center, and that kind of couples in, and I'll give you the explanation of that as we conclude the workshop. But the hotel that I was in was right on the corner there. And when I checked in, the guy at the hotel said, "Oh, I see you like quiet rooms, so I will give you a very quiet room." So I get in my room, and I'm looking right over the construction site. And I'm an engineer, so I enjoy that kind of thing, right? Not everybody would enjoy that. But I was jet lagged, and this is when I first checked in. It was 7 in the morning, and I was quite tired and still sleeping. And I hear this beep, 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 beep. And what's going on? There's a crane right outside of my window that is being erected. And so in Paris, it turns out that cranes are unsightly. And so they don't like to leave construction cranes up all the time when they're doing construction projects. So they have what they would call portable cranes. And there you can see a picture of one of them at Les Halles. And construction cranes, given that they're unsightly, they need to be designed for a low profile. So they can't go much over the 7-story limit of the buildings within Paris. They have to be low profile. They can only be set up between 8 a.m. and 4:30 p.m. So what I was hearing was this crane going up in the morning, and then at 4 at night, it would come back down. And they need to be able to assemble that very quickly, which is what I was hearing when I was in the hotel room. So that is associated with the challenge that you are about to embark on. You are going to design a crane that can go from state 1, which is a very compact state, to state 2 in a very short period of time. And that is what you will do as teams. So the objectives here is to design a crane that can go from what I call state 1, and I will give you the dimensions. It's actually on the sheet that's on the table in front of you. It has to go from a very compact size, 30 centimeters wide, 50 centimeters long, and 20 centimeters high. It has to go from that state to one where it has the same footprint on the ground, but is 120 centimeters high in the vertical. And you are given 3 minutes to go through that transformation process. You're going to have about an hour to work on this, but when you test it or when you operate it, you'll have 3 minutes to do that. And then what you will have, you need to raise a bucket and a block, and we have materials for you that I'll show you in a moment, but you'll have to raise a bucket and a block from the ground to a height of 90 centimeters in 10 seconds. So that will be the objective. Rick, you have a question.
But sir, the RFP says a train that can go from state 1 to state 2 in 4 minutes.
Oh, that's a typo. The instructor had jet lag. Actually, in Medellin, it was 4 minutes, but they all finished in like 2 minutes. So I thought I got to make this a little harder. So it's actually 3 minutes. Thank you for pointing that out. He is. I think he might get an A in this course.
I want an A+, sir.
Oh, A is not good enough for you, right? You're one of those. Okay, so you'll have 10 seconds then to lift this. Now, how are you going to build this? Well, we have materials, and Scott and Sean will be working the store at the back. And the materials that we have consist of essentially these types of things. We have blocks. They're 1 1/4 inch blocks, and they have holes drilled in them. We have structural members. There's some that are 3 inch, 6 inch, and 9 inch. And we also have balls, and the balls have 3 holes drilled in them as well. And so those will be some of the materials and supplies that you will have. Other things that we have back there, there are clothespins, and they all have a price associated with them. We have buckets. Each team is going to get their own bucket. So you don't have to pay for the buckets. So what I'll do now is distribute the buckets. These are free. So each team gets 1 bucket. And there's your bucket. And there's also cable, and that is sold for $25 a foot. And we have a tape measure back there that will measure. And there are spools that are $40 each. And there's limited supplies. So we have, with only 4 teams, though I don't think we're going to hit the limit of our supplies, but we do have limited supplies of everything. So the store, this was the store in Medellin. We have a very different store here. I wasn't able to take a picture in advance, but the store is back there. And the engineering workspace, that was the engineering workspace in Medellin. This is the engineering workspace here. And so you'll be working around the tables and then there. What we will do at the conclusion, during it, we'll try to pull these tables out, but we'll bring all 4 of the project forward, and this is where you will operate. And so we'll do a 3-minute test where you assemble and then the 10-second lift. And this will all couple into a point system. So to demonstrate what we're going to be going through, this is state 1, and so you have to start with the crane and that kind of volume. If you don't satisfy this volume, you're going to lose 1 point in the point system, and I'll define that in a moment. And then what you need to do, you need to go into state 2, and this state 2 could look something like that. But in 3 minutes, you have to assemble, and then in 10 seconds, you have to lift the bucket and the block. Team formation. Well, we've already formed teams. Ideally, when you do team formation, you want gender diversity, school diversity, program diversity to bring new ideas to the creative process. 5 teams of 10 members. We have 4 teams, but that'll be fine. And the budget Each team is given an initial amount of funding, and the amount of funding that you get, we have funny money from the dollar store. So each team gets $3,000. And this is a cost minimize exercise. So the more money you have remaining at the end of the exercise, the more points that you will get. And somebody that was very clever in Medellin said, if I don't participate in this activity, I'll have $3,000 left at the end, so will I win the competition? And so there is a clause that you have to participate. So that is kind of what we have planned. It's skewed now because we're starting a little later, but I'll come back to that in a moment. The rubrics, I would like you to fill out the rubrics. As you think of things that students that we could assess them in terms of their creative aspects of this process, if you could fill that out, and then what we'll do is we'll consolidate those at the end and share with everybody. Point system. So we have financial points. You have your $3,000 each team. So you have to minimize the amount that you spend. And you're not going to be able to read this, so I apologize for it. But it is on your instruction sheet. What we have, we're going to take the total dollars remaining and divide by 1,000. That will be the first increment to the points. The second one is the state one size. If you don't fit in the size constraint, you'll lose a point. If you do satisfy, you get 1 point. The next one is if you can lift the block 90 centimeters, you'll get another point. If you can't lift the block 90 centimeters, you don't get a point. The third one is the ability to lift the block. If you're able to lift the block, you get a point. If you're not, you won't get a point. And then finally, the length of the crane arm. We'll take whatever length you get from the center line of your structure. So this is going to be measured from the center line of your structure, and we'll divide by 40 centimeters. So if you're 40 centimeters for your arm, you get 1 point. If you're 80 centimeters, you get 2 points, so on. And that will be the point system that we will be using. So with that, what I will do is I will turn it over to you. You now have roughly, it's 3:30. We'll give you until 4:30. So you'll get 1 hour. I'm going to set a countdown timer here. So feel free to begin the exercise. The store is back there. You can go and look at the materials and supplies. You can even buy things and then go back and return it if you decide that you're not going to use it. This store does accept returns, so you can test things out if you want. Oh, now they're saying they don't. We have grumpy storekeepers. Okay. No, there's no return surcharge. So you can go and inspect the things.
We are promoting failure. If you fail, you can go and repeat.
They're for my labs. I probably my lavaliers, so I can like mic them. I probably need them.
Twenty minutes to testing, 20 minutes to testing. Okay. Testing, testing, 1, 2, 3, testing, testing, 1, 2, 3. Testing, testing, 1, 2, 3. 10 minutes to testing, 10 minutes to testing. And when we test, there will be 3 people from the team that will be allowed to assemble the crane from state 1 to state 2.
Well, you need to lift it, right?
No, it's in increments of 1,000.
No, we're fractional points.
Fractional for the dollar. Fractional for the dollar. The length is fractional and dollars is fractional.
Do we have to pay for the cube that we lift?
Yeah. Okay, we're under 2 minutes to lifting. So if you have your crane ready, you can put it into the state 1 condition. And you can do it on top of your tables. We'll go around to the tables and do it that way.
In case if you need it.
How the French did it? Because now I'm curious to know how they pulled this off.
What's that?
Are you going to reveal how the French did it? Because I'm
You know,
curious to know how they did that.
do I have it here? I think would it be on my USB? It's an amazing
Yeah,
device.
that's what I'm curious now how they pulled this
It's
off.
a German crane.
It's a German.
Yeah.
They just modified it? Or?
No, they. Okay, we are now out of time. So, oh, look at that, we got a bell. So at this point, I would like to ask you to go to state 1 condition. So we'll give you 5 minutes to go to state 1. Oh, you go from state 1 to state 2 in 3 minutes.
Oh, you don't have to go back down to state 1 in 3 minutes?
No, we don't do the full cycle. So go into state 1 condition. But you're tall.
Wait, oh, you want to?
The whole crane, the whole crane needs to be disassembled.
We'll just lay it down.
But the footprint, the same footprint.
Okay, that's fine. Yeah.
No, it doesn't have to be. Yeah, it has to be in a truck or something.
No, because the footprint.
The footprint is like a truck or something to transport.
We have to break it.
There's 2 minutes left in the disassembly.
Is that gentleman of the official?
I was part of the team. I was kick off the team. I cannot participating.
Do you guys meet the dimensions? You check the dimension requirements? But you have that part there, that's got to be part of the crane, right? Yeah, everything needs to be in state 1. All the components need to be in the size for state 1.
Yeah, this is state
Everything. No, but you have all of this. That's not in state 1.
Apart from that, it's only this.
Well, you have 30 by 50 by 20, so.
No problem.
You're a little over 20 centimeters.
Is it not the bucket which is supposed to be above 20?
It's 50, so you're okay there. But and then here you would have, it should be 50, 30, 20.
Yeah.
So you're 50, you're 70, you're not.
Is it not this, the best?
No, the whole thing, everything has to be in like you see that over there? They're in a 20 by 30 by 50 volume.
No, then you can take this.
No, we don't get it.
It's either a 0 or 1.
Sir, door not sir, door not sir. Door not sir.
You're talking about collaboration.
You guys,
Yeah, we had to push those square things on really hard to get it down.
that's why they're so hard to take apart after. Okay. All right, so we're now going to go into testing. But before we do that, okay, so what I'm going to do now, I'm going to come around and measure your state 1 volume condition. And so let me just borrow this. This has, yeah. So the official recorder will be Sean. Sean has a spreadsheet that will calculate the tally automatically.
Sean would have that.
So team number 4. This is team number 4. Their original condition, we have a little, let's see, 30 centimeters.
Yeah, 30.
Okay, that's 30 by, well, that one's kind of sticking out a bit.
28?
It's close to 50.
Thank you, Judge.
And 20. So they meet the original volume condition, team number 4.
Which one is that?
That would be the state 1. State 1, they get a 1.
Give them an excellent.
And team number 1 or team number 4, how much money do you have?
A lot of money.
So could you count out your
No, I
money?
put 3 kids through university.
We got discount.
We have a good accountant. Gosh, you are so good. Thank you so much. It's too much. We can even give a loan to other people.
Anybody need the money?
So 1115.
1115. So if you could enter dollars remaining, 1115. Thank you. And when we're done, if you could return the money to the bank, but you can wait now.
Scott, can you get the money back to the bank? So divided by...
Yeah, okay, so we're going to move to this team now. Sean, I'll move over here. Your team number, what was your team number? Your team number 1? So this is team number 1. Their length it's less than 50. So that's good for the length. The height is 20. And the width is 20. So for state 1, they get a 1. And how much money do you have left?
1110.
1110. So if you could enter that. And that money will, and our bankers will check.
Isn't it supposed to be 50 by 30 by 20 high?
They can be less.
What?
They can be less than that.
Can be less.
Yeah. No. It can be less.
Okay, instructions, -10.
Sorry. Okay. Team number 2, we will check the original volume.
Okay.
Okay, they're 50
Feel, my dear.
by 50. Team number 2 gets a 0 for initial condition. Because you have to be in 20 centimeters by 30 centimeters by 50 centimeters.
We don't have that.
So what about all that?
What? It's
All of that.
That is not...
But that all has to fit in this volume.
Oh, all of it.
Everything.
That doesn't explain.
How much money? How much money?
2,000 plus.
No, we have to count it.
Yes. How much money? How much is that? Oh, 2,000?
Excuse me?
Hey, you cannot have 2,000.
They say 2,000.
They said 2,000.
That's what they say.
That's impossible.
Oh, seriously?
2,000.
No, that's negotiable. Seriously, how much? This is the money I have? Yeah. This is 2,000. You cannot.
We can do the math on it. We'll do the math. We'll count it.
We are going to do the math later.
Okay. Okay, so we'll now check.
Let me check the money.
Oh, you want to check the money? Okay, well, they do that. I'll check the volume. 50, 30. I did this already, 20. Okay, so you guys meet, and how much money do you have left?
2240.
2240. Somebody want to evaluate? They're saying that's team, what number, team 3? Team 3 is saying 2240 left.
6.
Team 3? 2240.
Let's put everything in first in the state 2. And then
2.24. Okay, and then they got a 1 for the volume.
Their money's right.
Okay, and this team, you got the money from them?
You count it this way. No, 2,260. Really? Yeah. Left us, yeah. 200.
Okay, so now what we're going to do is go into the state 1 to state 2 transition. So three people from each team are going to assemble. We are about, Rick, we're starting the process of assembly. So starting, when I click this, that's when you start to assemble. Start now. 3 minutes, 3 people. 3 minutes. Yeah, go.
You know what? Don't let Farzad in there, please. Kid, quit being so polite. You gotta get in there, guys.
It's already started.
One of the teams is done. No extra points.
Ninety centimeters.
They're going to lose points. They're trying to optimize the point
You
game.
know, and like with us, I must say, the rules here, it says a specific size. So we shot for that size.
So I should say
Exactly.
maximum. The second team that is done. One minute left. 1 minute left.
I think there is one thing that I would like to say.
Time is up. Stop building. Stop building. Okay. So what we're going to do now, let me set 10 seconds here. I got to go back. Okay, we're not going to start yet, but what I'm going to do is go through and measure the length of the arm from the center line of the structure. So this is team number 4 from the center line of the structure. We have 60 centimeters.
So that's the length
So
divided by
that's length, yeah.
So that's 60.
60, yeah. Oops, sorry.
1.5, yeah? We give them
Yeah. And this is team number 1, and I'll put the center line of the structure here from the tower. So, Sean, Judge. Okay, team number 1. They are, if I go from the center line, they are 78 centimeters. We divide by 40. Team number 1? Okay. What team number is this? Team number 2, from the center line of the structure, which I'll take here. It is 57 centimeters.
57, give them 1.425. This is team number 2? Count that in the center line. You're number 2?
No, I put the center line of the structure. Team number 2. Now, team number 3. Team number 3, I'll put the center line of the structure here.
No. Center of the structure.
Center of our footprint. Center line.
Highest stomach.
I think
114 centimeters.
114. It doesn't work. They get 2.85.
Okay.
But it's not functional. Okay.
Okay, now, so we have that, and now max clearance will measure. You know what I'm going to do? Let's check max clearance right now. Team number 3 gets a 0.
No? Yeah. What?
Are you going to go 90 centimeters?
No, sorry, no.
Okay. Team number 2, their clearance is 110, so they get a 1. Team number 1, they are 110, so they get a 1. Oh, we got to move a table so that we have a datum. Okay. I'll do it from right about there. Okay, so they're 120, so they get a 1 as well. Okay, so now we go into the lift phase. So put your block in your bucket. Make sure the bucket is on the table. Everybody put their bucket on the table. And I'm going to need some other judges to help assist. Farzad, did you want to judge, being that you've been kicked off a team? He was kicked off a team. And Sean and Scott, you can help as well. So Sean, you want to monitor that team? You can monitor this team. Scott, you want to monitor the cantilever, and I will monitor this team. So we have 10 seconds to lift the bucket to the top.
If it's shorter, we get credit?
If it's shorter, well, it's got to go 90 centimeters.
No, less time.
No. There's no time benefit.
Okay, so can we go?
Just wait, I'll start it. Is everybody ready? Okay, I will do a 3, 2, 1 countdown. So 3, 2, 1, start. Okay, let me stop the timer. All right, so we have, what team is this? Team number 1, for the lifting, they get a 1. And what team is that? 2. Team 2 gets a 1 there. Team 4 gets a 1. And team 3, okay, they did not lift the ability to lift 90 centimeters. Zero. Okay, now. Is that the total? Okay.
They won't.
Okay,
Because they have lots of money.
Okay, so we now have the total point count. So the third place on the total point count.
Group number 4.
No, it's 2, isn't it? Third place?
65, and this is 585.
Yeah, so that's in third place.
Yes.
So team number 2 comes in third place.
Who is number 2?
There's a cost calculation. How come?
Cost is entered in.
No, but the other costs are more.
Okay, so that's third place. Second place is team number 1.
Oh, good job.
They copy our design.
And first place is team number 3.
Even though he stole our point. Okay, we are going to kill you on January.
They got 0 for a couple. I think it was their length of the arm. And then the money. No.
They beat us.
No.
Okay. Our students.
Okay, so what I would like to do so that was an exercise in project-based learning that you just all engaged in. Questions, a discussion. What I would like to say, first of all, now I'm not sure how many people filled out the rubric, but would you include the points in the rubric? How many people think the points should be in the rubric for the grade for the students? That team thinks they should. Other people, how do they feel about the points in the rubric?
Well, if they won, you've got a problem with your point system.
So you're saying you would not include the points in the rubric? Because it can be either way. That's fine. Oh, they would have it in, well, the rubric would be in advance. You would give them, they'll have the point system and the rubric in advance. That's right, that's right. So what Rick is saying is that if the points are not in the rubric, the students will ignore the points. Okay, another question. You see 4 designs here. How would you assess creativity? How would you assess creativity if you had to formulate? Jim, did you have a comment?
Yeah. The only way that you have basis for creativity is if the design functions the way it was intended. Otherwise, I can just simply do something completely unrelated, and then...
So you're saying a non-functional design that's playing the point game? Okay. And that's why you were saying negative point system for not satisfying the requirement.
Did you have a specification for what was required?
Well, I mean, it wasn't as detailed as it could have been. But whenever you're doing a design project, you would have that, right? You would have...
On the specifications by making the 90-centimeter lift a specification.
So you have to meet that. So that could go in your rubric. That could be one of the items in the rubric, right?
It says 120 centimeters in height.
That's the max height. It can't go above that.
Because of your story to set the whole
Yeah,
thing up,
yeah.
Your parents,
Yeah.
whatever,
Uh-huh.
we all got the idea that this thing had to function as a crane.
Yes.
Which it does.
But
What's
you
that?
did specify the height's got to be 90 centimeters.
That's how high they high it. Oh, so you're saying that they didn't
is
satisfy
specified.
that?
Needs to lift a bucket. plus
Rick,
square.
it does say,
It says-
needs to lift a bucket, square block from H equals 0 centimeters to 90 centimeters. So in a way, the functional requirements were not met by Team 3.
That's what I said. If they win, your point system, your roof goes.
So your point system would had to have been, everything then times the 90 centimeter lift point.
Actually, just one discussion point.
Sure.
The objective of this exercise, is it delivering what you're supposed to think a crane is or answering what's written on that page?
There were criteria.
Yeah, but that equation was the...
Well, the grand scheme is to think about how to assess creativity. That's the grand scheme of this exercise.
But a big part of creativity is going against the rules or following the rules or finding ways to better answer the rules.
While meeting the specification.
Yeah. Yes.
Right?
Yes.
Well, no, actually, we didn't really care about meeting the customer's objectives. We know what we cared about.
Okay, I have to, there's 3 more slides and then we'll wrap up. So let me just, I'm going to turn off the lights, just a moment. Oh, really? Oh, that would be good. Okay, so I just want to wrap up because we're ready to go downstairs. The background for this workshop, it was inspired by the skyscraper workshop. And here we have a photo. This is something that we did at CU Boulder back in 2009. And you can see Rick is actually in this photo right here. So, yeah, that's Rick. So he's been through the exercise before. And this beautiful structure here was my team's design, which I kind of liked. So that's a picture of the window out of the Paris Hotel. And there you can see the crane. And it's a very amazing crane, the way that this thing lifts up and it articulates out. It's like an accordion. And they build it very, very quickly. But there's another picture here. And off in the distance is the Pompidou Center. You cannot see it. How many people have been to the Pompidou Center? And what is the Pompidou Center known for?
Structure, the design.
The external and creativity and art in Paris. So there is a picture of the Pompidou Center from the front, and it defies Paris architecture completely. And it was built, I think, in the 70s, early 70s, late 60s. But in the Pompidou Center, there's a gift shop. So I told you that I was stuck in Paris for the night. So I ended up going to the Pompidou Center in the evening, and I went into the gift shop, and I saw this in an area of the gift shop saying creativity. And I knew that we were going to do this workshop, so I thought, hey, that seems like a good thing. It's expensive Tinker Toys. So I ended up buying one of those, and it's called Picado, which is essentially Tinker Toys. And so that's kind of what the concept was based on after seeing that. However, the cost of one container of Picado is €59. That kind of breaks the budget, right? When you think about how many things that have to be built. So what I did, knowing that we had this workshop on, I ordered from Texas all the raw supplies. 1 1/4 inch balls, 1 1/4 inch cubes, the structural members. There's 500 feet of 1/4 inch dowel. And you know how long it takes to figure out how to drill a hole in a ball? Drilling a hole in a ball is not a trivial task. And the reason is when the drill bit hits the ball, it wanders. And in order to get the hole going straight through the ball, it's very, very difficult. So it took 2 days to figure that out. After watching tons of things on YouTube, experimenting, trying, had to build a jig. So this afternoon, the panel was talking about jigs. Built a jig for that. And my father-in-law and I, he spent the majority of the time in my basement garage, spent 215 hours working in the workshop to build all of the materials and supplies. And in the end, there were 4,500 drilled holes, 3,100 bandsaw cuts, and 15 days going into making the equipment for the workshop. And the final thing I'll say is that I did offer this last week in Medellin, Colombia. And when I was leaving the airport in Medellin, I was brought down for interrogation and inspection, I should say, of the content of my suitcase, because I had 60 pounds of Tinker Toys in it, and I think that triggered some things, and they thought it was kind of strange. But I got out of the country without problems. So anyways, that's the history of the workshop. Thank you all for your participation.
Okay, Farzad. So you can just put this part in your pocket, and I'm just gonna guess I can lab you right there.
Thank you.
Yeah, you can put that in your pocket. Let me just find a better way. Yeah, like right. There's
Okay.
good. Perfect.
And should I put a? Should I?
Here, you can like coil the cable or anything. I'd like, you can clip it to you, whatever is good.
No, I mean that. Should I off and on?
Oh no, it's already on. I'm doing everything from the camera.
Okay.
Then they put it on, assembled their own instrumentation amplifier circuit. So that just throw it in, that's fine, I'll get it after. And then acquired the data with a program got Sean to take inventory, make sure everything's really. And then stuck it in a spreadsheet.
Absolutely.
And they had a design goal for their measurement. They had a design goal for their measurement. I made up a foolish task, which was detecting the difference between a fox and a hen on a load, on a force plate at the entry of the hen house. So that gave them a, how accurate does the measurement have to be?
You can get going. I don't think all
Yeah.
the faculty are coming.
I am about to write an answer.
Yeah, let's go and Janet will do it. These are ours. These are ours. Yeah.
The argument for downgrading your lab equipment.
Sorry, what was ours?
Yeah. Yeah, put all this, which is ours here.